Hi, my name is Sahel, and this year I have created a glass cleaning robot. This short video is a brief overview of my project. I will be showing you the components I have put into my robot and explaining their functions. Also, I have included a video of my robot climbing down a window halfway through its development, a video of it climbing at a 45-degree angled surface and at an 80-degree angled surface. Let's take a quick tour of my window cleaning robot. It has 7 suction cups in total, 1 at the top, 2 on each side, and 2 at the bottom. The suction cups are lowered onto the glass using a pneumatic piston that fills up with compressed air and pushes a rod down. The movement of the robot is guided by 4 tack switches on each side. When the switch is pressed, it sends a signal to the microcontroller to let it know that it has hit the side of the window. At the top, I have placed a squeegee to clean the window as the robot descends. I have used a DC motor to raise and lower the squeegee. On the top of the squeegee is a pneumatic component similar to a vacuum generator. It takes in compressed air and creates a vacuum in the outlet. I have connected a small water tank to this outlet so that it sucks up the water when the vacuum is created and sprays it out on the other side. To control the pneumatics of my system, I have used solenoid valves that are controlled using MOSFETs on the circuit board. These run at 24 volts, and when current is passed through it, it allows the flow of air to continue, like a tap that controls water, only this is controlled via electronics. This is the vacuum generator that creates the vacuum for the suction cups to hold the device onto the glass. It takes in compressed air and creates a vacuum in the outlet. To control the movement of my robot, I have used DC motors and a rack and pinion. Over on the other side, I have 2 voltage regulators to step down the 24 volts input to 12 volts for the motors and 5 volts for the microcontroller. I have also put in a DC fan to cool the system. On the top, I have an on and off switch, power LED, power input, a 20x4 LCD to give instructions to the user, and lastly, my own logo. I wanted to create something unique, something you wouldn't see every day, but yet at the same time, something that would help people and make their lives easier. As I've grown up, I've always wanted to know how things work and why things work the way they do. This thirst for knowledge grew into a passion when I was introduced to the world of electronics and mechanics. The idea of a glass cleaner actually came to me when I was a lot younger, but instead of creating a glass cleaner that would clean windows, I created a glass cleaner out of Lego Mindstorm to clean the glass of our coffee table. When I came home from school one day, I found my dad struggling to clean our living room windows because of his back and knee problems. This motivated me to create a robot that would clean the windows for him. After doing some further research into the issue, I found that high-rise window cleaning is one of the toughest and most dangerous jobs in the world. So I thought, why not design my robot so that it could be developed for high-rise window cleaning later on. I then searched online for window cleaning robots and found 3 that caught my interest. Clean Ant and Gecko use vacuum to stick to the glass, whereas Windoro uses 2 permanent magnets to hold 2 units together on either side of the glass. The problem with this is that it cannot climb across windows, and since I want to develop my robot for high rises, I went with vacuum. Currently, my robot is not fully functional on a 90-degree window. This is because a few adjustments need to be made to the height of the suction cups to prevent my robot from tilting backwards due to the force of gravity. All the rest of the electronics, mechanics, and pneumatics of my system work perfectly. In the near future, I plan to develop my robot further. My ideas for future development include faster movement using new motors, a new circuit board with an upgraded microcontroller, ultrasonic sensors instead of tach switches to guide its movement and also to calculate the area of the glass, a graphics LCD, a piezo to alert the user when the clean is complete and when the pressure in the system is dropping, gauges to monitor the pressure and vacuum levels, and finally a total redesign of the placement of the components in the main body to make a smaller and more compact system. I hope to carry on sharing my passion with the world, and one day I hope to be a successful engineer. Thank you for watching.